This is Milestone 3 for section 11-28. So our need finding, Yerb is an alien exchange student. He is visiting Purdue from Alpha Centauri for a few weeks with 69 other students. And with this, he will need a solution to purify water for great quantities that will reduce the amount of chlorine and fluorine in the solution, have the water be 2 to 4 degrees Celsius, and that is easy, simple, reusable, modifiable, and shareable. The water in Purdue doesn't have a low enough pH for the aliens, as stated in several interviews with the aliens with Professor Mendoza. The water can harm them if it isn't cold enough and if the pH isn't low enough, which is required to be at 3. And the temperature needs to be 2 to 4 degrees Celsius. Our goals or our criteria for success include that it is reusable, shareable, and modifiable. It should be 2 to 4 degrees Celsius, should reduce the pH to 3, and it should reduce the chlorine to 5.5 milligrams or less, and reduce the fluorine to 0.4 milligrams or less. Each alien must have 2 gallons of water for 2 hours during the duration of stay at Purdue. And while they're at Purdue, the pump of the water, our solution, must also pump out at least 1 liter per 5 seconds, or 0.2 liters per second. We have several constraints concerning our limited budget. Right now we don't know our budget, but we know that it will be affecting us in the future, so the most inexpensive solution is the best. The solution must be completed within 3 weeks or by February when the aliens touch down, and the solution must be self-sustainable, as requested by the aliens. Our stakeholders include the alien exchange students who will be using our solution. Purdue University will be providing us the budget for the solution, and the designing teams who will be designing the solutions which will be considered to be used. The manufacturers and distributors will be creating the parts for our solution that we put together ourselves that we design, and the technicians and builders will finally put together our final solution. This is our weighted decision matrix. As you can see, we rated, or our criteria were constant water output, if the water was cold, if the water was pure, if it was its acidity in obtaining water, and if it was inexpensive. We weighted those as 5, 10, 15, 15, 5, and 10. And throughout our weighted decision making, we decided that ascorbic acid was the best possible solution. Out of those solutions, though, we had the UV filter straw, the UV lid for a water bottle, the boiling water, and ascorbic acid and the carbon filter. UV light was considered because it dissociates chlorine water, or dissociates chlorine from water, which lowers the pH of the water and reduces the chlorine content of the water. We ended up throwing out this idea because the UV seemed to be too complex and complicated and seemed to be too high maintenance. Boiling the water just was it wasn't self-sustainable enough. We had to throw it out. Ascorbic acid was the best possible solution because it was the most inexpensive and it had the highest results. These are our pros and cons for all of our several solutions. And with that, we concluded that ascorbic acid was the best possible solution